Okay. Hey, y'all. Thanks for coming to my session. My name is Erin Schnabel. I am now a creator of things at Red Hat. We are here to talk about metrics for the win, metrics for understanding your application behavior. A few things to know as we get started. Really the most important one is that I do make ridiculous things, and I'm now making ridiculous things at Red Hat, and I used to make ridiculous things at IBM, and you know, I'm getting used to the change, but it's good. I do hope as we go through this session that you do take the opportunity to ask me things in the chat. This is a new format, and so you should be able to just ask questions as we go along. I think that would be pretty cool. So please do feel free to do that. I'm excited about the prospect as I'm recording this earlier, so feel free. So when we are talking about metrics, we're talking about it usually in the context of observability. And of course, within this J4K conference, we're talking about it in the context of Kubernetes. When we want to talk about an observable system, or when we want our system to be observable, right? It's the question is, can we understand what's going on with all of our services based on output? Output can take several forms. I actually include basic health checks in the notion is like one element of what makes a service observable. It's just the basic, is it alive? Is it a zombie? Is it ready for work, right? Those are just basic outputs within a whole context where you have many services. Knowing which ones think they're healthy or not, right? That's good to know. It's good context. It helps you understand the whole operational aspect of your system. So health checks count. Metrics are all statistics and analytics and trend finding, right? You're not doing any diagnostics with metrics. What you should be doing is prediction. And I realized as I was working on this talk that this is sort of like where this whole talk came from. I was trying to explain to people that metrics are really important, and that application specific metrics, like not just like the generic ones, but like, things tied to the application were really important. But I was having trouble articulating why. And so this whole talk came about because I was like, okay, fine, I have to show why. Fine, I'll go show why. But it goes back to something that I did when I was an intern with my dad one summer. And I spent that summer in a quality control office at a manufacturing plant, measuring dimensions on roller rocker arms for the engines of 3.1 liter engines, I think. And so it's like we would get samples, part samples pulled from the line, and we'd have to measure their dimensions, and we weren't doing that for fun. The point was, you would measure these dimensions and they would be analyzed throughout the day, like time series, right? Over time, we're measuring throughout the day, and then what you were looking for was changes in the dimension that started to indicate that a tool on the machine was starting to wear out, and so that way you could replace the tool proactively. So you would never get to the place where you were producing a part that was out of spec. You would always identify the problem, replace it before, right? So all of the parts, you were always producing parts that were perfectly good to use forever. That was the point. And so like using metrics for that purpose, right? I always felt that then application specific metrics, like it's not just like heap is not even just enough, right? It's like metrics are always good for being able to diagnose stuff before, like to be able to anticipate things running off the rails, I guess is what I'm trying to say. So yeah, metrics, numbers, analytics, trend spotting, that's what you're looking for. Logs that's where all the meat is. When the problem does happen, you need the logs so that you know what happened specifically, right? That's where you can find, okay, this is the request that came in, and here is what happened line by line by line, and here's the services that were used, and oh, there's the problem. Fingers crossed. It's not usually that simple anymore, but right, that's where all of your detailed diagnostics are. And you absolutely need that in a PD sense to be able to understand what happened and to be able to figure out what you might need to do to resolve a problem that ends up being related to a bug in a service. Distributed trace, it's all about the connective tissue, right? You're looking at the relationship between services with distributed trace. It's all the context that goes end to end. So here's the user request that came in, which triggered this service, which called those two services, which then triggered these events. You know, it's like, what is that whole flow? How are those things related? So that you can start to understand, you know, if, you know, what things are related to which things when everything's falling on the floor. That's a lot of things. But when you're looking at observability, there are also two roles that need to be considered. And this is just in a general sense, right? The infrastructure, Kubernetes, any smart orchestration engine, it can do a number of things out of the box, right? The infrastructure has to be somewhat defensive, you know, because it has to handle all comers, right? So Kubernetes has basic probe behaviors so that if you have a service that's dumber than a box of rocks, it can still tell whether or not it's alive or not because the port opens, or, you know, it's got some defensive basic behavior that it can use to try to infer what's happening on the inside. Kubernetes can, or metric systems around Kubernetes, they can measure resource utilization on the node and things around, or they can measure, they can monitor what's happening with the container, even if they can't see what's in the container, right? So there's a certain amount of generic monitoring for metrics, for example, that the infrastructure layer can do. The infrastructure layer usually also is the one that sets up the backbone, or you know, whatever mechanics you need to collect and then aggregate your logs. And you can also have pieces in the infrastructure that make sure that spans have been created. So that's maybe every time it's there, you know, a request passes through a gateway or a proxy, a span context might be created if there wasn't one there already, so that the infrastructure can provide some guarantees that there will always be a span present. What the infrastructure can't do is like language or applications aware health or liveness checks. It can't know from a generic sense whether or not a Java application server or a Java application is actually ready to serve things, right? The specialized probes it can't do. It can't do any application specific metrics. And I'm going to take that concept probably beyond what you're ready for, but you know, that's the point of this talk. It can't obviously create your log entries for you. It's kind of a duh, but you know, you actually do have to emit your logs. Most importantly though, with your logs, you should be making sure that you aren't including, you know, PII data that needs to be protected if you can help it. And you should be thinking about what logs, you know, you should be putting some thought into what logs you are emitting to make sure that they will tell the story that you need them to tell, so that you can see where things may have gone off the rails. The secret sauce of just enough logging is, man, that's a tough recipe to figure out sometimes. But that's definitely on the application developer to do. And the last piece is with distributed trace. Even if the infrastructure can make sure the context exists, the infrastructure can't always ensure that the right things are related in the way that they should be. Context propagation, even if you're using it, even if it happens via a library, is still something in the application domains. It's in the application's domain, right? You still have to make sure that the context is propagated with the request that comes in to whatever else happens afterwards. The context is then propagated appropriately. So that's, you know, it's just something to remember, is that those are the roles that you have. But we're going to go back today, and I'm going to push you really hard on this one. I want, and again, it comes back to my, I think my experience. It's like, I believe strongly that when you write application, or when you write metrics specific to your application, you will find bugs you didn't think you had. You will be able to have a better understanding, isn't it? You will know that your application is behaving the way it needs to behave. And you may uncover, I did not in my case, but my case, as we will discover, is somewhat odd. You may end up coming up with things where it's like, if this starts happening, things are going to go really wrong, right? It's like, I can't tell you what that mystery statistic might be, but I definitely know that you're not going to have it if you've never thought about writing it, right? You might have something that your application expects to do, and if something else starts happening, it's just, you can tell it's going to take a nosedive, right? It's that case from when I was young, and the inner diameter of the hole on the rocker arm, if it started to creep out, right, it was like, okay, the tool has to be replaced, or otherwise, we're going to have bad parts. So metrics aren't just for ops, okay? And so as we go into this next part, we're going to still use Prometheus for our time series data. We're still going to go to Grafana dashboards. These metrics are very application centric. We are not going to talk about JVM metrics. We are not going to talk about HTTP metrics. So there's no throughput, no heap size. We are going somewhere completely different. We're going to talk a lot today about monsters. This story started a year ago, when it was the beginning of the school year last year, and I offered my son, who was 10 at the time, to be a dungeon master, a game master for him and his friends. I did not put a cap on that offer. So within a very short period of time, I realized I was going to be herding 6 boys and 1 girl for my daughter when she decided to play, through dungeon crawls. I don't know. I had no idea what I was doing, but it was like, 6 boys that are 10, focus. It's going to be a challenge, right? It's like I had to figure out how all this was going to work and how I was going to keep them all engaged and focused. And so I wrote an app for that. At the time also, I was preparing a talk to work with micrometer metrics. So as I said earlier, like, I've had a really strong opinion about the importance of application specific metrics, and it was getting to the point where I had to go write it. I had to show what I was talking about because it was just time. So the two things kind of collided. I had to make this talk to show using micrometer. I wanted to demonstrate the value of application specific metrics, and I had to learn everything about Dungeons and Dragons in like 0 time. And so this is the result. This is the smashing together of things. So this monster combat application that I wrote, the general idea is that I make monsters fight each other until there's only 1 left. I have a few endpoints that I use so that I can control how many monsters within reason, how many monsters are fighting each other. Actually, at this point, I think I need to change the endpoints. I need to add more. I haven't yet. There's not going to be a pop quiz about this part, but I do want to go through monster attributes and their funky syntax, just so that when we refer to it later, you'll feel like, yeah, all right, I remember that a little. So monsters in Dungeons and Dragons have a couple things, characteristics, right? They have a size, and there's a finite set of sizes from tiny to gargantuan. It's a nice bounded set. They all have a type: Fey, celestial, humanoid, plant, ooze, dragon. I don't know, there's another one that I'm not remembering. Still, finite set. It's a little bigger. There's more types than there are sizes. All monsters have an armor class, which is how hard it is to hit them. And then they all have hit points, which is how many attacks they can take right before they're gone. All monsters have weapons: a bite, a claw, short sword, short bow, flail, morning star, club. I don't know. It's quite a long list of weapons. Those weapons do different types of damage. Now the types still kind of a broad set, but it's more bounded. Piercing, slashing, bludgeoning, poison, as you can see, cold, fire, necrotic, acid, something. There's a few others. But anyway, you have a type, and then they all do variable amounts of damage. Hit points, if you can see from the hit points and the damage, they have a string that's formatted in a certain way. And that's a notation that says, so if you do the parentheses part first, the bite damage is you roll 2 d10s, 2 10-sided die, and then you add 8. The average roll, the average value for that roll is a 19. So it's the average first, and then the dynamic roll string that you need to use to get that value. The last thing I want to mention is that it's not really a big deal, is that some of these monsters have multi-attacks. So they might have multiple attacks per one turn, which can really accrue some damage. When you're thinking about attacks, you have to think about hits and misses, right? So if I'm going to attack a monster, I will roll a d20 to see if I hit. If I roll a 20, I got super lucky. I do the happy dance because not only did I hit them, but it's a critical hit, which means my damage is doubled. That's awesome. If I roll a 1, that's a critical miss. And if my son is now my DM, which he is, he will go find the fumble table and we'll roll something else hilarious because, I totally dropped my sword or stuck it in my foot or who knows what. Critical miss, no damage. If it's otherwise, right? You're either taking an attack my d20 roll plus something because I'm good with that weapon, and I'm comparing it to an armor class. So I rolled a 12, your armor class is 10, I hit. I rolled an 8, your armor class is 10, so I miss. That kind of thing. Or there's a different kind of attack that involves a saving throw. And that is like the dragon breathes poison breath at you. Okay, you're going to get hit by the poison breath. So the question is, do you roll well enough to get out of the way so the damage is halved? That's generally what happens, is you get half damage if you can move out of the way well enough. So that's enough about that. Now, what I was trying to learn in a very short amount of time was combat rules, because I knew the boys were going to be the most interested in combat. And in fact, it's what keeps everybody the most interested at the moment is combat. So I was able to scrape 215 monsters off of a wiki page. I parsed all the wiki stuff, put it into JSON, and that's what I used to then create encounters that take random monsters and make them fight until there's only one left. We create the encounter, they roll for initiative, which is just like we would do at the table, which puts the monsters in order. They then take turns attacking each other, either with multi-attacks or with their spell save DC, their spell attacks or whatever thing. And they do that until only one of them is left. I want to share some perspectives with you in case you're like, I don't really care about Dungeons & Dragons. Why are you telling me about this? So I wanted to know about that stuff. I wanted to be able to sit down at the table and work with my kids and have some understanding what normal was for an encounter to begin with, right? That was one part of it. It's just this whole new DM thing. But as I was writing the rules, which again, my other objective was just to make sure I had codified the rules in my own head, I started to realize there were little things I was doing that could change how the game worked, right? Or how my encounters worked. And so I thought, this is the kind of thing where if I'm observing this and then I want to tweak this algorithm later, I can see what the result is and I can start to compare whether or not that does what I thought it should do. And then there's the last part, which is just, is this even working at all? Is this even doing what I think it's supposed to be doing? So now here we'll take a look at some code and I'll show you minimally. Here's what the encounter resource looks like, right? So I said there's a couple endpoints. We've got an any, which is any number of monsters within a range. We have face-off, which is 2, and we have melee, which is basically more than 2. Here's where I create the encounter. I set how many that was, how many monsters should be in the encounter. I have a notion of a target selector, which is where I have a few algorithms that I've kind of developed for how monsters pick other monsters to hit with things. And then when I build the encounter, that's when initiative gets rolled. But most interesting for us is that here is one round of an encounter, which will go and get all the monsters to fight each other one in a row. I record the result as soon as that round is over. And then I record the result when the entire encounter has been completed. And you'll notice I'm not using any annotations for metrics in here. And that's because, and I will talk about the details of some of these later, but when I'm using the result, like I'm using information from the result. Here I'm recording the total rounds. I don't know the number of combatants before the encounter was run. So I'm running the encounter, and then I'm creating a distribution summary. This is a micrometer distribution summary, which means I will get a count and a sum. So here I'm recording the total number of rounds in this encounter, and I'm using as values like the number of combatants. Remember, this is a bounded set, and the target selector that was used for that encounter, and the difference in size in the monsters from that encounter. So I'm recording that information when it's done. This kind of thing it's how you get the most from gathering metrics to begin with, and it's not suitable for annotations. This isn't easy to know a priori or to pre-register a priori without having like this exhaustive list. Blah. Like, no. You just don't do that. So I'm not a fan of annotations for metrics. This is why, this is how I did it. I also, though, it's a preference of mine, I put all of the metrics in this one class so that I could change, alter tags, rename, whatever I wanted to do, just from within one place without having to chase things all over the code base. I kept everything nice and contained. And from the perspective of the endpoint, this is a very non-invasive end round end encounter. Like, it's a non-invasive API, and then I get all the measurements out the other side. But I wrote it, so of course I like it, right? So if we look at the numbers, we'll come back to some of those code snippets. I know I went by them a little fast, but if we look at the numbers, we are collecting numbers in a time series. So x-axis is time. Prometheus in this case is going to be scraping these processes at an interval. It's a fixed interval. It will always do that, and it will just observe whatever it observes. So you have Prometheus just continuing to collect anything it collects. It will append to the previous series. Within that collection, or around that collection interval, right, as I'm making measurements, those measurements then, right, feed into the data that then Prometheus scoops up and collects. In the case of Micrometer's distribution summary, for example, every time I have a round or an encounter that finishes and I'm recording those results, I'm taking, remember what Micrometer is storing. It's storing the count and the sum and the max. And so those values get collected. If I have 5 encounters that happen before Prometheus scrapes them, because I have the count and the sum, like the max is just observed, it's just the gauge, so it's whatever was the max when it got scraped. But because I'm always accumulating the count and the sum, it's like Prometheus gets to see all of the values because it gets to see all of the aggregated values, if that makes sense. So it gets to see all of the measurements. And because it sees all of the measurements, that's what makes it so that I can aggregate across my 2 instances, because I effectively get to see all of the data. So I can re-aggregate them across dimensions. When we talk about dimensions, here we'll go through a little bit. So we got our time series database, or our time series data. If I look at rolling the dice, we'll splice out one of the pieces that I showed earlier, where we're looking at just how we're rolling dice. And so every time the dice is rolled, right, I'm recording which die it was. Darn it, I want to like highlight things and then it makes the page go, but it's fine. So it's like which die, this is a D10, which face, in this case it's a 9. Prometheus, when it's collecting, will implicitly add 2 other, they're configurable at the end, but it will add 2 other dimensions. It'll add the instance it was collected from, and it will add the job that it was collected from. So it adds 2 additional dimensions. And then it's still that 1 numerical value. So in this sample, the 9 was rolled on a D10 16,724 times, because it's just a counter in this case. But what we can do with that data is, let me show you, we'll just keep going. So when you talk about dimensional data and you get to a cardinality explosion, this is why people say that, right? Tags and labels are for statistics. They're not for storage, and they're not for diagnostics. So yes, Prometheus is adding like just the instance of the service that it's pulling data from, and the, you know, it has the name of a job that the metrics are pulling from. But the important thing to know is that these numbers compound, right? And you shouldn't be afraid. Cardinality, high cardinality can still tell you a lot of things. There's just, like, don't go for infinite. Don't use an almost always unique value like a UUID or a request ID, right? Every unique combination ends up being a new series. So just be cautious. So I wanted to get to this view, right? And then I can show you some other cardinality examples, right? So I took all of those dice faces, right? And in this case, time is still there. I'm just plotting based on the series instead of based on the time. So I'm still looking at, this is also an early version of this dashboard, I'm still looking at how many of each number was rolled within the last 15 minutes or something. We're still in a sliding window. But if you're paying attention, something should look really, 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 really funny. And that's this, right? The D12s are just completely not right. There's nothing, it's just, they're wrong. And I would not have caught this, right? This was 28,000 rolls total. It was 1,400 of them were of the D12. Some of them worked, but a whole bunch of them didn't. I had missed a switch. I had missed a case in a switch statement. So I knew the D12 was rolled, but it always rolled a 1 or a 0 or I don't know what. It just wrong. Like it flat out bug, and I would not have caught it. I would not have caught it without this view, without aggregated metrics, just looking at all of my dice rolls. Because I had tests, I had other things, just completely missed a switch statement. Thank you, aggregated metrics views. If we look at hits and misses as another aggregated view, this is another case where we're looking at across these dimensions, right? So we have hit or miss, attack type, damage type in this case, where we're trying to look at the damage per, the damage of attacks in a round. And if I look at how some of these values are, right, I'm taking 3 Booleans, whether or not it's a critical, whether or not the hit was saved, and whether or not it hit at all, right? I'm taking those 3 Booleans and putting them into one value, one hit or miss value. And then I have another, this was actually added much later when we started to really poke, when I with friends, I started to get feedback, right, on what kind of data I was capturing. And I was getting interesting questions about what the difference in damage was with an armor class attack versus these difficulty class, these DC based attacks. So we added one for that. And oh my God, this is comedy of errors. This is money right here. So the first time I really put this together, I was just trying to get like any kind of list. That's just wrong. Like I just wanted to see what is that? critical saved hit is not a thing. It doesn't exist. So this instantly, oh my gosh, all 6 stages of debugging. I'm pretty sure this was the one where I took whatever the game engine was and I dumped it on the floor and just started over because it was a mess. It was bad. Thank you, Aggregated Metrics, for showing me that I had an invalid comment. Like this was a combination of things. Again, it's really hard to test. And I had tests, but they went down one particular path. I needed to get to the number of permutations of monsters fighting each other that happened to get the right combination of the right combinations of, I have a feeling that came from the case where in a DC, it was one of the early days when I was just trying to handle these DC-based attacks. And I just needed to get the right combination of monsters together to have that actually happen. And that, yeah, not good. So thank you, Aggregated Metrics, for helping me spot another bug that I did not find in my tests. So I fixed that, right? Yay. No, still wrong. And this is another one where I don't think I would have spent hours of my time combing through my JSON output, because that's where this ended up coming from. So this misses should be like less common than hits, but way more common than critical misses and hits. And what had happened is that when I ingested the data from all those wiki pages, I forgot a plus on my regular expression statement. And so, yeah, everything had a max armor class of 9. So pretty much everybody hit. So that's what that happened. Yay. Win number 2. See, for the win. It's all the winning with Aggregated Metrics helping me find my boneheaded coding mistakes. So we're going to take a little reminder here. With statistics and working with aggregates, you're always looking at changes to measured values over time. And it's almost impossible, it's always almost impossible, right, to work back to any single entry. So by the time you're looking at rates and rates of increase, where you put the time back, so you get your x-axis back into something interpretable, I can't emphasize this enough. You're not getting back to that one thing. You're looking at what happened over the last 15 minutes-ish. And especially in my case, I'm the minor, low-level, I'm just hacking around case, and I still have 2 instances. So it's like you're averaging across, yeah, just don't go backwards. So with this hit or miss thing, if we go back to this data, so now we're going to go look at the dashboard so we could look at the aggregate data plotted as increases over time. So we get a sensible x-axis in most cases that helps us understand what this damage is. So we're going to look at this round attacks ones, which is the hit or miss, attack type, and damage type, and we'll see what we can infer from it. So let's go over to our attack dashboards. So we do have dashboards here in Grafana. I have just a quick throwback, right? Here's the updated dice roll one, right? So we still have that one, it still works. Let's take this dashboard, we'll go to 3 hours, the last 3 hours. So if we go attacks by hit or miss, this is just from that data that we gathered. We can learn a few things. So this is a nice stacked graph, which means, everybody's piled up, there's no overlapping lines. So what we can learn from this is that critical hits are uncommon, they're low, exactly as they should be. They're both uncommon. Hits are more common, thankfully, than misses, right? 1.7 to 0.9, right, ish. So we have hits more often than we have misses, that makes the kids at the table happy, so that's good to see. But then we also can see that hits based on a difficulty class, right? Those are also comparatively rare, and you can see it in the numbers down here in just this counter that I have, right? Is that they're just extremely uncommon compared to the numbers based on armor class. When they do happen, these DC-based attacks, it's good to know that they are saved more often than not. So that's good to know also. And the reason that's interesting is because we're going to start looking, now this is the same data. just want to remind you, the same data. We're going to slice the dimensions a different way to look at damage. So if we look at damage by attack type, this is something, and again, because we're using the increase, we get our x-axis back. Otherwise, this would be a ratio from 0 to 1. So we're putting we put the time unit back in, we get our x-axis back, but we are already super far away from our original math or our original measurements. Like, those are gone. We're just looking at the trends now. So the average for an AC based hit, average damage for a hit against an armor class, is 15 damage. It's fine. We would expect, because critical hits are double, that a critical hit damage should be double. It's about double. Perfect. Great. That makes sense. Everybody's happy so far. Because crits won't, you don't always know. It's not going to be a strict double because of, it doesn't always happen. Your 20s only happen sometimes. So you don't know where on the AC level it was when it had the double. So your double's not, your critical hit average is not exactly double of the hit damage, if that makes sense. I'm saying it badly. That's okay. I didn't really appreciate this until I started this crazy activity. So you always know that when something has a saving throw required, like you always know that, like, that's going to be rough, right? Like, that's going to be scary. I didn't know it was going to be that rough. Like, that's critical hit stuff. That's bananas is what that is. That's just bananas. So these are all of the DC based hits. And that's just ludicrous. Thankfully, when you save them, you can probably survive. Like, saving these things, like, holy cow, that's just ridiculous. Whew. And so like your average damage, if you take hits or miss or saves out, I mean, you can still just see like your average for, if you take criticals out, right? Or average them in, I guess, whatever. Your averages are hovering 9.7. And then this, like, just nuts. It's just crazy. That's just it's so spiky, it's so dangerous. I had no idea that was like critical hit level crazy. It's just nuts. Same data again. We're going to slice it a different way. And we're going to look at the damage type. So we have slashing, piercing, bludgeoning, 3 most common types of damage by a long shot. Everybody else is a little pile here. And if you look at the average damage per type, you can see this tight line in the middle, and that is slashing, piercing, bludgeoning, hovering right near the overall average. So the most, and this is by design, I'm quite sure, the most common damage types hover around the overall average. Poison and lightning will wreck you. I have run this for hours and hours and hours and hours and hours. Poison and lightning always will wreck you. And so I got curious. Okay, so let's break down poison and lightning. So if we look at poison and lightning by attack type, right? Poison, it doesn't matter if you get it in an ace, like an armor class based attack, which is usually like you get hit with a club and you get additional bonus poison damage. Sucks, it just sucks, it kills you. So you have poison damage there, and then you have poison with a spell save, usually. And you can see the poison on a saved hit versus poison on a hit, right? You definitely want to be able to do any kind of saving throw you can against poison. A difference from 49 to 14, yes, I will take that. Thank you, Constitution modifier. Now, holy cow, when did that happen? A poison critical hit happened at some point. That was 92. That's a lot of damage. So poison, just don't mess with poison. That was my lesson learned. And that's all from data that we gathered. It's across 2 systems, it's averaged, but I learned that poison is terrible. As a game designer kind of person and that sort of thing, that this is the kind of stuff that makes me want to get some more aspects of the game working, like figuring out how to do grapples or any other kind of thing to just see how punishing those are. They're just harder they were harder for me to understand how to model the first time around. Now, I think I showed in the code briefly, where is it here? I will show this. I split the attacker damage out. And that's because the attacker has a name, much higher cardinality, and then the attack name also much harder cardinality. So it got to the place where if you look at the attacker's damage, like it's just between claws and sea hags and harpies and owl bears, like it's a lot more. So I split it into its own series so it wouldn't be overlapping with the other ones. And this is pretty much the limit of what you can do with high cardinality data like that. The best you can get, you can't graph this, it looks like silly string, but you can get a reasonable list of like top 5s and bottom 5s from what happened, you know, or here's your top attacks by weapon, right? Here, these are just most frequent attacks, right? Or most frequent attacks on those by creature or by weapon on the farthest out. But the top 5 attacks by damage, lightning strike, lightning breath, poison breath, cold breath. But the bottom 5, right? A club doing 1.3 points of damage. The interesting thing here for me is the scale of difference, right? Your bottom 5 are almost at 0 damage average. Most everybody else in the pile, the overall average is around 10, but the top 5 monsters in this list they're up in the 30s, right? They're twice as big as the average. It's just ridiculous. So like the difference between that's why you get one shots when they got, it's just different. It's ridiculous. So yeah, don't fight really hard monsters. They hurt you. It's great. Now the last piece I'll show you, and we are getting kind of close to time, but this again is still summary. I'm still working with a distribution summary that has a count and a sum, so I can do averages. And I'm looking at the number of encounters in a round. And part of why I wanted to do that was to see if there were choices that I was making, you know, that or things that were just happening that controlled how many rounds would be an encounter. For example, if you have 2 monsters, which means they have no control over target selection, they're just going to bash the other person until they're done. Is there a pattern? And it turns out the size of the monsters absolutely matters. If you have, and I had zeros, like the size deltas of 5s don't happen very often, so they fall off the graph first. But a size delta of 5 is pretty much the same as a size delta of 4. 5 is like a tiny versus our gargantuan. It's a one-shot, smash, dead, right? Totally expected. And you can kind of see when they're the closest to the same size, that's when the encounters last the longest. Completely makes sense. Common sense confirmed. Yay, there's sanity, hurrah. When you pin it to the number of monsters, right? And so this label is wrong. This is still a target selector, right? So that's overall encounters by target selector. And then we have the rounds per encounter. And when I'm talking about target selector, I mean like, how am I choosing who the next person to hit is, right? Here it is. So you can start to see it's been sitting here for hours now. If they try to pick the biggest first, that's what makes the match. It makes it take the longest. You have 4 monsters hitting on each other and they pick the biggest first. It will take almost 9 rounds for them all to kill each other. If they go at random, it will take only 7. Same if they pick the smallest or perhaps the healthiest, right? Biggest first is a losing strategy, is all I have to say. And that's pretty consistent. I've seen that over time. Now, encounters by difference in size when you have 4 monsters is somewhat similar, right? When they're the same, you have the most rounds. When they're the farthest apart. Now, the thing with 5, with the tiny versus gargantuan, is that when you have 5 monsters, there's always usually someone else in the middle of a similar size. So it gets a little tricky. There's always a confounding factor when there's at least 4 monsters in there. So that was the encounter dashboard. So I hope at the end of this, like I would like you to think about what you can learn about your applications if you add your own metrics. If there's something else that you've got to this thing where I'm not going to be able to test this number of permutations of things, can you count that? Can you use a metric to measure and just look at what happens? Is there a way for you to observe how that stuff is happening in an aggregate such that you don't have to make your eyes bleed analyzing logs? I really encourage you to explore application metrics to find bugs that you aren't going to find otherwise, because you're not going to go crazy writing infinite permutations of tests or, you know, going cross-eyed staring at logs. So that's what I hope you got out of this. Thank you again for your attention and your time. If you have any other feedback, let me know. Again, thank you so much for coming.